Okay, thank you everybody for joining this webinar. As Lindsay explained, I'll be talking about the new release of our concept software, showing some of the new capabilities and the features and the benefits of this latest release. So just before I start, just really to recap some of the philosophies that we have here at Romax Technology whenever we develop our software. And really just how that has influenced the requirements and how that has influenced the specification of our software product. So with everything we develop, we want to make sure that the engineer or the user can get the answer that they want very quickly. So we don't want to be waiting for some sort of analysis that might take 3 to 4 days to complete. We want to make sure we get the answer quickly. And if we get the answer quickly, it means that it's much more likely to be able to influence the design. We want to make sure that the answer is correct. We want to make sure that the answer will be accurate. Okay, that's fairly obvious. We don't want the engineer or the user to be spending a lot of time building their model. And the way that we want to achieve this is that we want the model to be defined by recognizable engineering parameters. So we want to make sure that as the user is building up the model of their gearbox, of their transmission, of their driveline, they're actually using engineering parameters. We don't want the engineer to have to be worried about mesh density. We don't want the engineer to have to work out a lot of dimensions and clearances and spaces. We want the model to be defined by engineering parameters. We also don't want to be considering components in isolation. We don't want to be we don't want to have to look at the bearings in isolation, or look at the shafts in isolation, or look at the gears in isolation. We really want to make sure that we're doing a full system analysis and we're considering all of the interactions between the components. We want the models that we create to be multi-purpose. That is, we want to be able to use that same single model that we've built to look at different phenomena. So we want to make sure that the model that we create, we only have to do it once, and then we can use it to look at lots of different things, whether it's for durability or for efficiency or for gear wind or for general dynamic behavior. We want to have a single model. You invest your time to build the model up, and we've said that we want to do that very quickly, but we want to use that single model for a number of different analyses, a number of different phenomena. And we also want the results to be interpretable. And by that, I mean that we want the results to tell us something useful. And these results need to directly influence the design. So we want the results that we get out of the software to be useful and to be able to be to directly influence a design change. So we want the results to tell us something useful. So they're the general sort of guiding philosophies that we have when we develop software here at Romax, and what I'll be showing now is how all of these things have really fed into what we've developed with our new version of the concept software. So our new product, our new version of concept, we think it really allows the user to do pretty much everything required to create a finalized concept design of a gearbox or transmission or a driveline. So we've got intelligent modeling. We've got full gearbox and driveline modeling, and we have modeling templates. So this is all about being able to build your model of your gearbox or transmission or driveline with built-in intelligence within the software to guide you, and also with a load of templates in there to assist with the creation of the model as quickly as possible. In terms of bearings, we have bearing load calculations, and we also have bearing databases, and these bearing databases will really assist bearing selection at a very early stage in the design. In terms of gears, we've got fully automatic gear ratio optimization, and then we've got gear design, manufacture and rating capabilities. For automotive or for vehicle applications, we also have a vehicle performance simulation. And then in terms of system analyses, of course we can calculate speeds and torques and loads, we can consider cost, we can consider efficiency, and we can consider packaging arrangements. So all of these capabilities are wrapped up in the new version of Concept, and I'll go through each of these things in turn now in quite a bit more detail. So the first thing to understand is that we can build these models very, very quickly. So I've just got a very brief video that just shows the speed of model building. So first of all, I'm just going to build up a very quick 5-speed manual transmission. Some of you might have seen this video before, so we'll go through it fairly quickly. So I've positioned 3 shafts within the gearbox design space. We can specify dogleg angles and center distances, and then we can add in gears onto the shafts. So you can see how quickly we can put the gears on the shafts. We don't have to worry at the moment about the positions of them too much. We're just now adjusting the shaft positions. So this is all about being able to build up your models very, very quickly. So we're meshing the shafts together. Each of the gear pairs is being meshed. Just adjusting some of the shaft length here. And you can see here, we've got a 3D model. Okay, the gears at the moment, we've not set the ratios, so we're going to adjust the gear ratios. You can do that either by dragging and dropping the meshes as you see here, or you can specify the ratio directly. So again, this is all about trying to build your model up very, very quickly. So you can see within just literally about a minute, we've now got our gearbox with our gears and our shafts defined. So the gears are just at the moment defined as ratios. We now have to say that these gears are not rigidly fixed onto the shaft. They're actually fixed on via synchronizers, so we just adjust that. We then define the power flow, so we know where the power is going to be coming into the gearbox. We know where the power is going to be coming out of the gearbox. We can then specify where these shafts are going to be supported, and then we have we've got our model. We can then define the power flows. So we can define first speed going through the first speed gear pair. We've got second speed, third speed, fourth speed, fifth speed, and so on. And as we do this, because the software knows how things are meshed together, we know how the speed of each component is related to its adjacent components, whether it will have the same speed or whether it will have a speed dictated by the gear ratio. You can see now we've got the power flows, and we've calculated the speed and torque ratios for this particular gearbox. And then I think as you've hopefully seen before, we've of course calculated the speed of all of the components. We know the inner speed, the outer speed, the relative speed of all of the bearings, and all of this is calculated pretty much instantly. And we can see the engine speed against the vehicle speed for first, second, third, fourth, and fifth gear. I'll show you later on in the presentation how we can do some automatic optimization around this. But this is really just to give you a bit of background on what the sort of core functionality of Concept is. So we've calculated the speeds. We're now looking at the forces and the torques applied at the bearings. So what we've got many customers using Concept for at the moment is to identify these bearing forces and then really take these bearing forces and work out how to design their gearbox housings. So you can see here, hopefully you can see the small red arrows. That is representing the bearing forces. So these can be used to assist with the housing design. So you can see for each of the load cases, the forces are different, and you can see them visually replicated here. We can then move on to the gears, and we can see how even just based on the gear ratios, we're getting some safety factors and some for bending stress and contact stress, And these are based on a simplified formulation of the ISO 6336 gear rating. And then we can go through and we know what gear ratio we'd like to achieve. We could then say, well, I want to have a 2.4mm gear, and then the software will guide you to give you appropriate tooth numbers and give you gear ratios as close as possible to those that you require. So we've got a tooth sizing calculation here. Okay, so I'm just going to jump out of here now and jump back into my presentation. So hopefully that's given you some sort of idea as to how quickly you can build up the models. Obviously that was a very simple model, but really exactly the same philosophy holds, whether it's a planetary gearbox or a DCT gearbox or maybe an axle. Whatever type of gearbox, you can build it up just as quickly. So in this new version of Concept, we think we have pretty much everything you need to model the complete driveline. So we have gears, shafts and bearings, if you've seen. We also have either engine or motor components. We have wheels that can be defined. We have power splits. We have CVT components. We have chains and belts, and we have synchronizers. So I'll show you these in a bit more detail a bit later. So as I said, it's not just the manual transmissions that you can build up. This is a 9-speed automatic transmission, and we built up this model in literally 20 minutes. So you can see here, for each of the speeds, we have various clutches and brakes are going to be engaged for each of the speeds, and that gives us all of the speed ratios. Just a reminder, if you do have any questions, please feel free to enter them into the question box on your toolbar, and we'll be able to come to those at the end of the presentation. Within the models, we also have a large number of modeling templates. So the user, for example, can say, well, I want to have an automotive transmission, I want to have a 6-speed automatic transmission, I want it to be a planetary arrangement, and maybe I want it to be option 2B. And then the user will specify the ratios that they want in that gearbox. They can specify the overall dimensions, and then the model will be created. So the idea of this is that it means that we can build up these models even faster. So even if you're not happy that you can build up your model in 20 minutes, here's a much faster option. And it also gives much more assistance to the novice engineer. So there's a whole load of intelligence built into the software that will enable you to create these models and really investigate different design options really as easily as possible. So just in terms of the templates, you can create your own templates as well. So if, for example, you would like this gearbox to become a template, then you can convert it into a template, and you can give it various keywords. So you can say that this is maybe an automotive gearbox, maybe it's an 8-speed gearbox, and you can build up your own catalogue of model templates that you can use across your organisation, or you can keep it on your desktop. And then when you come to select from those template libraries, you can say, well, first of all, I want to select all of my automotive gearboxes, I want to select all of my 5-speed gearboxes, and then you'll get a list of gearboxes here that satisfy those search criteria. So we will be shipping the software with a number of templates, but also giving you the ability to create your own internal templates. So again, this is all about being able to build your models as quickly as possible. Vehicle performance simulation. So what we want to be able to do here is understand the performance of the entire driveline of the entire vehicle, and really be able to help you choose appropriate gear ratios. So the things that we can get out of here, as I say, are the ideal gearbox ratios. You can get things like the tractive force plots, the power and torque plots, and also fuel consumption. So talking to many of our customers, many of our users of the first version of Concept, they said that they had these type of tools already, typically in Excel spreadsheets, but what they wanted to do is have a more seamless way of combining that functionality into concepts. And so we've essentially implemented this type of either an Excel spreadsheet or maybe some MATLAB code. We've implemented that into this version of concept. So the things that we've had to add to really enable that, as I say, we now have an engine component, and so we need to specify the maximum torque curve and the minimum torque curve of the engine, as well as the efficiency map of the engine. So that can be all included within the concept model. And then we can perform this vehicle performance simulation, and that can give us things like a top gear selection. So you can see here we have the tractive force plots and the maximum tractive force and the resistive force, and then we've got these different plots at different levels of inclination. So all of this can be used for your top gear selection and to get the optimal gear selection. So you can see here that you can either calculate your top gear ratio based on the maximum speed in top gear, or it can be calculated for the maximum speed in the top gear but one. Bottom gear ratio can either be calculated from the manoeuvre speed or from the wheel tractive limit, and then you can choose whether you want to have a geometric progression of your ratios or a progressive progression of the ratios. And then this is really helping you to create, or the software is giving you information to select your gearbox and ratios. So once the software has told you what gearbox ratios, then the software then helps you further for doing the individual gear pair or gear set optimization. So we know what the overall gearbox ratios are that we want within the gearbox. What we want now is, we know the gearbox and layout. The software will now help you to optimize the individual gear pair or gear set ratios to achieve the desired gearbox ratios. So this is especially useful and especially suitable for planetary gear arrangements. For example, in this arrangement here, we've actually got 9 speeds and reverse, of course, and we've got 4 planetary gear sets to achieve those speeds. So previously, people would tell us they'd just be adjusting these ratios really manually, getting as close as possible to the desired gearbox ratios. And that was quite a laborious, quite a manual process. So what we've done, we've implemented a very automated optimization algorithm. So the way this works, we start with our gearbox and layout, and we specify what the desired gearbox ratios are. We specify these. We specify which gear sets or which gear pairs we're happy to adjust or to modify, perform the optimization, and then the software will give you a number of candidate designs, and then it will tell you how near we are for each of the gear speeds. So this is first speed, second speed, third speed, fourth speed, fifth speed, sixth, seventh, eighth, and ninth, and reverse. The dotted lines going across are the desired gearbox ratios, and these dots for each of the gearbox ratios shows just how close we've got to the desired gearbox ratio. So you can see we've got a number of candidates here, so maybe the top 4 are all showing that we've got very close agreement. So we've got four options here for gear ratios that will give us the required gearbox ratio. And then as we come further out, you can see the red lines are showing that we're getting further and further away from the desired ratio. So this is a completely automated process, and this really shows a number of options now that we have that will give gearbox ratios as we desire. So it's a really powerful feature, especially for complicated planetary arrangements. Okay, so we now know what gear set ratios or gear pair ratios we need. We now can move on to actually design the gears. So this is a really easy to use gear design and analysis process for spur and helical gears. So this gear design process, because it is integrated into the rest of the process within Concept, it means that we're not having issues with transferring data between different software tools. So this is, again, this is a guided process. There's various optimization algorithms built in here. And the main benefit of doing this gear design within Concept is that you're not having to transfer data between different software tools. Lots of our customers are saying to us, yes, we've got our gear design tools, but we're not able to, or it's very difficult to transfer our gear design parameters, our gear design data between all of these different software tools. So the reason for really embedding this gear design process within Concept is to reduce the issues that we saw people having when they were trying to transfer data between their software tools. Okay, coming up to bearings. So we have now included bearing catalogues into Concept. So this means that the bearing selection can start to be made at a very early stage of the design process. So we know what the bearing loads are, we know what the housing loads are, we can then calculate the dynamic capacity, and then the software can really guide you to select bearings that will be suitable. So, as I say, bearing catalogues will enable bearing selection based on calculated dynamic capacity, and it really just means that these bearings can be selected from the catalogues, and we can check for packaging, we can check for loads, we can check for dynamic capacity. At this stage, we can't do a very detailed bearing analysis, we can't look at bearing stresses, we can't look at non-linear bearing stiffnesses. That is still the domain of RomaxDESIGNER, but you can pass this model directly into RomaxDESIGNER for further detailed analysis. We also have cost and efficiency and packaging checks. So in terms of efficiency, we're going to have loss models for gears, bearings and clutches, or you can have a user-defined component loss curve. In terms of cost, we can have user-defined material cost per kilogram. So you can see here we can define the unit cost for each of the materials within the software, and then we can get material costing for each of the components. Of course, this can be overruled, this can be overridden by the user. You can put scaling factors in for different components to accommodate or to account for different manufacturing methods, but it's really just to give a bit of guidance on costing. We also have packaging checks both in 2D and 3D just to ensure that your design is suitable for the packaging space that you have. Something that our customers at version 1 were Concept were demanding was having multiple power loads. So previously we would have a single input and a single output, whereas now you can have multiple power inputs and multiple power sort of outputs. The reason for this is that, for example, in a DCT transmission, we might want to model 2 inputs, and we might want the power to be coming out at maybe the wheels or maybe either side of a differential. So there's a whole number of reasons why we might want to do this. And we've also got now the ability to link the power loads. So we might want to say that these power loads are going to be taking out the same amount of power, and we can do that now within the software by essentially creating linked power loads. Synchronizer analysis. So previously we would just have said that these gears were, they had a sort of, they were connected to the shaft by a connection that you could turn on and off. You can now actually connect that via a synchronizer, and you can also, and we can define the synchronizer cones if you want to, and we can do synchronizer sizing now within Concept. So you can select your synchronizers, whether you need a single cone or a double cone, and we can really understand exactly how these synchronizers are going to be will be performing in terms of shift time and shift load. So hopefully that's shown you all of the new capabilities that we're going to have within Concept, and we really think that this gives the engineer or the designer pretty much everything they need to create these finalized concept designs of a gearbox or a driveline. Just a little bit about where this fits into the process. So this is a typical vehicle design and development process. So we start off with product planning, moving into concept design, into detailed design, prototype manufacture, prototype testing, through into testing, to manufacturing, tryout and into production. And as we all know, we have different departments within the organisation will be involved at different stages. So for product planning, we've got the vehicle planning department, powertrain planning department. For concept design, that tends to be the design department, but they tend to start quite early and go through right into detailed design. But of course, they have some involvement right through to final production. We then typically have the CAE department that pick up at the end of the concept design stage and go through and support a whole load of activities. Our RomaxDESIGNER product typically sits around here. So we see our RomaxDESIGNER products being used by design departments and CAE departments. And then Concept really works seamlessly with Designer and picks up right from the product planning stage right through towards the detailed design stage. And the important thing here is that this concept design, this concept model that you create can feed into Designer as well as feeding into various CAD packages. So just a very quick overview. Concept allows you to rapidly create and visualize gearboxes and full drivelines in a drag and drop environment. We can investigate and optimize complex gearbox and driveline layouts. We can do the gear, bearing, synchronizer and clutch sizing and selection. We've got a gear design process that is now seamlessly integrated into a defined design and analysis process. We can assess noise, durability, packaging, cost and efficiency. It has full compatibility with RomaxDESIGNER, CAD and multi-body dynamics software. And the benefits of this is that it really gives you an ability to innovate very easily and quickly, and we think that it gives you an improved quality and reliability of manufactured products due to being able to do the early analysis. And the fact that we now have a seamless workflow from concept to detailed design really helps to link departments and groups within an organisation, reducing the development speed and reducing the amount of errors. And all of these things really mean that we can become faster to market with reduced development costs. So, as I said, this second version of Concept, it really builds on the strength of version 1, but with much broader modelling and analysis requirements. And I think what's important to note is that pretty much all of these developments that I've been talking about for the new version of Concept, they've come from feedback from the major automotive and industrial OEMs and Tier 1 suppliers that have been using the first version of Concept. So it's due for release in September 2013. And if you want any more information, please feel free to contact either me directly or to contact your local sales representative. As we said earlier, if you have any questions, please feel free to type them into the question box. But for now, I will hand back to Lindsay. Thank you for your attention.